Welcome to the SAT Math series. This is test number 3. This is test number 3, section 4, and I believe it is from question 31 to 38. Okay, so let's do number 31. So they ask us about the value of x of the angle x in this case, number 31. Okay. So first of all, for this geometric problem, let's take a screenshot of the image. I will put it in Paint to solve it together with you. Alright, so here's our image. Okay, I might just cut it and crop it. Alright. Okay, so number 31, they asked us about the value of x in this case. So x is here. The little red angle here. You can see that's the red part. We have to find out it. So we know. Let's make let's consider this angle here, y. And I just let y to be blue, y. Okay, so we know that x and y lie in the same triangle, right? We know that x and y lie in the same triangle. Therefore, you can see and it's gonna lie in the same triangle as the 45-degree triangle. So we're gonna have an equation that is x is gonna be equal to 180 minus 45 minus y, right? Minus y, right? Because x, y, and the 45 degree makes up a triangle, so that's just 135 minus y. Okay, so now we have to calculate y. So you can see we have a pair of opposite triangle. No, not triangle. We have a pair of opposite angle here. You can see that's shown by blue. So we can see that we have a pair of opposite angle here, and by opposite angle theorem, opposite angle are equal. Okay, so on this side, this is an I as well, y as well. And inside this triangle, we can make an equation to find our y. Okay, so we can find our y because we know y is equal to y plus 40 is equal to 180, right? So we can figure out y is 100. So y plus 40 is 180 because y and the two angles of 40 degrees lie in the same triangle. Okay, so we can plug in to find x. So x now is equal to 135 minus y, right? So that is just 135, sorry. So it's just 135 minus 100, so that's 35. Alright, so that's 31. So 31 gonna be, the answer is gonna be 35. Okay, alright, number 32. So let's make it a little bit clear. Alright, the technology company finds that 11 out of every 600 mail sent to its server are lost. At this rate, how many emails are lost if 42,000 mails are sent throughout the server? So number 32. We know that the ratio of loss is 11 out of 600, right? So all we have to do is we have to multiply that by the number of emails sent to the server, which is 42,000. So that's gonna turn uh, 770, I believe. So yeah, it is 770. So 32 should be 770. Okay. Number 33. Okay, sorry. Number 33 is about the graph that is the patent applications versus the number of applications of the US and the China. Okay, so they ask in which year did US and China have the same number of patent applications? Alright. In which year did the US and the China have the same number of patent applications? So it's actually the intersection of the graph, right? So it's actually the intersection of the graph. So let me copy print screen. I'm gonna save this. Let's say 4. Alright, let's copy cut this. Alright, here. So they ask in which year did the US and the China have the same number of patent application? So you can see the mutual number of patent application is actually the intersection, right? It's actually the intersection of these two graphs. So it is at this point, right? This intersection point, okay? And this intersection point is lying between 2008 and 2010, right? So it's actually an intersection point, and we have to find out the year of the intersection point. So number 33 should turn 2009, which is between 2008 and 2010. Okay, so we just choose the year of the intersection point, and that's the year between 2008 and 2010. Okay, so it's gonna turn 2009. Okay, yes. All right. Number 34. Okay, so let's try new number 34. What do the answers? New 5. So for x bigger than 3, okay, bigger or equal to 3, that's fine. We have fx, so we have a function, okay. So we have fx is equal to the square root of x minus 3 over 2. So for this condition here is x has to be bigger or equal to 3. Okay, now we have f of n equal to 3. Okay, so that means that the square root of n minus 3 over 2 is equal to 3. Okay, alright, with the condition of course is n this has to be bigger than 3, right? So n bigger or equal to 3, right? Okay, so we can square both, so we have the equation here like this. 3 is equal to square root of n minus 3 over 2. So we can square up both sides. So 9, 3 square will be equal to square root of n minus 3 over 2 all square. Okay, so we have 9 equal to, okay, square root of 3 square Square root of n minus 3 square h is n minus 3 over 4. Okay, so you can figure out very quickly n minus 3 is equal to 36, therefore n equal to 39. Okay, and for the answer it is 39. Okay, alright. Okay, alright. So let's move on to number 35. So five last one. Okay, five last one. That's very good. So we have minus 4k plus 12 is bigger than or equal to minus 24. And it asks us about the possible value, the maximum possible value for 3k. Okay. Okay, so let's do that. So 35. So we had that minus 4k plus 12 equal to minus 24. So in this exercise, to find the maximum value of 3k, we're gonna do the transformation of this inequality. So let's try to do that. So minus 4 times k plus 3 is bigger or equal to minus 24. So we can divide it both sides by minus 4, but the equality gonna change side because we divided for a negative number, right? So on this side, okay, so minus 4 times k plus 3 divided by minus 4 has to be smaller or equal to, because when you divide it by a negative number, the inequality is going to change sign. So minus 24 divided by minus 4. Okay, alright. So in this side, k plus 3 is left, is smaller or equal to, okay, on the right side we have 6. So we know that k is smaller than equal to 6 minus 3 is 3. So 3k is smaller than or equal to 9. So 3k is smaller or equal to 9, which means the maximum value of 3k is 9. Okay, it's 9 right there. Okay, it's 9 right there. Okay, number 36. So they want to divide 3x squared plus x plus 2 by x minus 1. Okay, to do that we have to use some we have to think a little bit. So we have to try to do some transformations. So so this can be equal to, okay, so 3 x squared minus 3x, okay, plus 4x, because 4x minus 3x x plus 2 over x minus 1. And you can see this part right here is divisible by this part right here is divisible by x minus 1. So I'm gonna demonstrate it. So you can separate the things out. So it could be like we can separate this into two fractions. So 3x squared minus 3x over x minus 1 plus 4x plus 2 over x minus 1. Okay, so this could be transformed, right? 3x times x minus 1 over x minus 1. Okay, and plus in this side we're gonna say 4x minus 4 plus, okay, 6 over x minus 1, because minus 6 minus 4 plus 6 is plus 2. Okay, so that's gonna be uh, okay, this side we keep it the same. So on this side 4x minus 4 is divisible by x minus 1, so we're gonna separate it out, and we're gonna add the last part is only 6 divided by 6 minus x minus 1, like this. Okay, so we're gonna separate 6 out from this sum and let 4x minus 4 divided by x minus 1. Let's make another transformation for clarity. So the first term we still keep it the same. This term is actually 4 times x minus 1 over x minus 1. Okay, so this is reducible already. You can see here we have x minus 1, and in the numerator and the denominator we also have x minus 1. So what we are left with is 3x plus, on this side is 4, and we plus 6 over x minus 1. So sum this transformation, and that is equal to ax plus b plus c over x minus 1. So we can figure out a is equal to 3, b is equal to 4, and c is 3 equal to 6. Therefore a plus b plus c is just 3 plus 4 plus 6, which is 13. Alright, which is 13. So the answer of 36 is 13. 13. Yeah. It is 13 indeed. So for this equation, there was two ways to do it. You can do the standard polynomial division like this, but this is my preference. I'm gonna do the transformation. I'm gonna factor out the common factor of x minus 1, and then what is left gonna be what is remaining after the factorization is just the c over x minus 1. So that is required from the result, and therefore you can figure out a, b, and c. So my strategy is just factoring out x minus 1. Alright, that's quite good. Let's finish it with 37 and 38. 37. One restaurant serves burritos during lunches and dinner. On a typical days, 25% more burritos are sold during lunch than during dinner. If X represents the number of burritos sold during lunch, okay, okay, the total burrito sold in a typical day is AX, okay. Okay, where A is a constant, is day, okay. So we know that day is equal to lunch plus dinner, because they serve burritos during lunch and dinner. So day is just lunch plus dinner, and we know that dinner is 25% more burrito that so on a typical day 25% burrito are sold during lunch than during dinner. So dinner is actually 75% of it, which is 0.75x, right? Because dinner is because dinner is 25% less than lunch, right? Right? Okay. So AX gonna be just equal to lunch, which is x, plus so ax, right? Ax. Now it's just x, which is lunch, plus dinner. So 0.75x. That is just 1.75x, right? So we can figure out a is equal to 1.75. Alright, so the answer for 37 is 1.75. Alright. Okay, last questions. If the restaurant sell typically 360, if the restaurant typically sell 360 burrito during dinner, how many burrito does the restaurant typically sells during lunch? Okay, so 38. So dinner we know is that is 0.75x, and now we are given it to be 360, and now we need to find out the number of burrito in lunches, which is x. So it's just 360 divided by 0.75, and that's gonna be equal to 480. So I think it is 38 is 480. Let's check it out. 175. Foreign 50. Okay, I made some mistake here. So okay, I have made some mistake here. Sorry, you guys. I'm gonna check it again. Okay, sorry guys, I have made some mistake here. So in the official answer, if x is lunch, and we're gonna set D for dinner, so dinner is 25% less than lunch, which means x is actually 125% of D. Okay, so it's actually x is equal to 125% of D, which means that x is equal to 1.25 t. So for that we can fix d according to x, which is d gonna be equal to 0.8 of x. Okay, so ax now is just lunch per dinner, so lunch is x and dinner is d, right? So that is just x plus 0.8 of x. So it's pretty close, but the you could not say it's pretty close. We have to calculate this, right? So 0.8 of x, and that is actually 1.8 of x. Okay, 1.8 of x. So a is actually equal to 1.8. Okay, so a little bit close, but mistake. Okay, and for this thing, we're gonna have 0.8 of x is equal to 360. Okay, so x is just 360 divided by 0.8. Alright, so what is source number 38? If the restaurant typically sell 360 burrito during dinner, so we have dinner D to be 360. How many burritos are actually sold during lunch? So we said lunch should be x, right? So lunch. So we have the equation that is x and d, that is which is d is equal to lunch, right? It's d. No, it's day. So lunch. X is lunch and d is dinner. So we have x is just 125%, which is 1.25 times d. So we know that dinner d is equal to is equal to 360. So we can find out x, right? So we're gonna find out x is just 1.25 times t, which is 360 times 1.25, which is I believe it's 450, right? So yes, so that's 450. So yeah, so mistake in calculation, sorry. So there you go, that's the correct answer. So yeah, that's the end of the SAT lessons. So the answer for 37 and 38 is here. So thank you very much for watching. And any question, please comment in the comment section down below. I'm gonna check it. Okay. Goodbye. Have a good day.